All right, greetings, YouTube. It's your host with the most, the man with the plan. This is Beautiful Mind here with this midnight stream. I'm doing this in an attempt to have the video loaded and ready to go, so that way during class time I can just be available for questions and things of that nature. So my goal or my intent is to load these videos in advance so that I can be available during class time. Let me turn this down. Okay. So this is our, let's see, so this is going to be our stream for, this is going to be support for College Algebra, week 3, Monday. Let's see if there are any announcements. So we had exam 1. Exam 1 was due this past Saturday at 11:59 p.m. If you did not submit it, don't fret. You can actually still submit all the assignments on Pearson. There'll be a penalty. For assignments submitted after the due date or after the deadline, the highest you can make is at 80%. And honestly, I'm okay with you working on the quiz past the due date. The highest you can make on the quiz is at 79%. So what that means is that you can still submit exams late and things of that nature. Highest you can make on an exam is a C. Highest you can make on any other assignment is a B, right? Is a low B. And the highest you can make on an exam submitted late is a high C, right? I like to drink. That's funny. Anyway, so normally during class time I will pause right now, pause for the cause to see if there are any questions. But obviously, since we're not meeting in front of each other, again, as you have questions, just write them down, and you have to reach out to me. Okay. I'll be updating my grade book shortly. I would have done it over the weekend. I did notice that Pearson was kind of acting up a bit. So, we'll just kind of work things as they arise and things of that nature. Without further ado, let's get into the lecture for today. So today I'd like to talk about chapter 10. Okay, we have about quadratic equations. So we're going to actually start off with section 10.2. solving quadratic equations by completing the square. So some objectives here are to write perfect square trinomials and solve quadratic equations by completing the square. Okay. So perfect square trinomial is a trinomial that can be expressed as the square of a binomial. Let's see. So on the far left, we have some examples of some perfect square trinomials. If we were to factor these, for instance, this first one, we're looking for two numbers that multiply to give us 9 and add to give us 6, and that's going to be 3 and 3. In the second one, two numbers that multiply to give us 9 and add to give us -6. That's going to be -3 and -3. Two numbers that multiply to give us 25 and add to give us 10 are 5 and 5, and so on and so on. So this perfect square trinomial is a square of this binomial. This perfect square trinomial is the square of this binomial, so on and so on. Okay. Okay, let's see. Solve the equation by completing the square. Okay, let's actually work this one out. We're asked to solve this one by completing the square. I think there are a couple of ways of doing completing the square. One where you work entirely on one side, one side of the equal sign, and another technique where you work on both sides. I'm just gonna pick one and work that one. Oops. And actually, let me do like this. So let's get a copy of this. Come on. You're not gonna work? Let's try that one more time. There it is. And we're just gonna get some blank space. All right, let's work this example. So we're asked to solve this equation by completing the square. I'm just a fan of the lines. I'm gonna go to paper like this. It just helps me to write better. Let's go like this. And let's do this one actually. So we're asked to solve by completing the square. So let's start by getting a copy of the original. We have this x squared plus 6x minus 7 equals 0. So the first thing when we do completing the square is we have to get the leading coefficient to be a 1, and we're fortunate because it already is a 1 here, right? There's already an implied 1. So the next thing that I typically do, I'm going to move this constant term to the right side of the equation by doing using the inverse operation. So what's the inverse operation of subtraction? Or in other words, what's the opposite of subtraction? It's going to be addition. So we're going to move the 7 by adding it to both sides, okay? So then we have this plus this equals 7. So now the completing the square step comes in with, we have to do basically is b over 2. We have to say, we're going to add b over 2 quantity squared to both sides. Okay. So our b in this case is this 6. All right. So we're going to add 6 divided by 2 squared to both sides. 6 divided by 2 squared, right? 6 divided by 2 is 3, 3 squared. So we're essentially adding 9 to both sides. All right, so that's going to be 7 plus 9. This is going to be 6x. That's going to be x squared, and just to be consistent. Okay. So now what this does, I forgot to attempt. Now back at the beginning, you know, originally we were going to be looking for two numbers that multiply to give us -7 and add to give us 6. Yeah, we don't have it, right? Because it would have to be what? -7 and +1. But that adds up to -6. If we did 1 and -1 and +7. Let's see. I guess we could have jumped straight there, but I guess I went on and did this one because the question asks us to do completeness square. But anyway, let's just kind of keep going because it looks like we don't have to do it here. But this is just a demo on completeness square, so that's why we're doing it this way. So then, now if we look, if we go ahead and factor this on the left-hand side, we're trying to get to something of this form. Let's bring this down. But we want our double parentheses. All right, we have our x and our x, and we're looking for two numbers that multiply to give us 9 and add to give us 6. That's going to be 3 and 3. Plus 3 and plus 3. All right, and then 7 plus 9 is 16 on the right. So now we have x plus 3 squared equals 16. We can use the square root property where we can take the square root on both sides. And whenever we introduce square root, we must do plus or minus. So the square root cancels the squared. And on the left, we're going to have x plus 3. Square root of 16 is 4, so we're going to say plus or minus 4. And then subtract 3, so then x is going to be equal to negative 3 plus or minus 4. So then x is going to be equal to, let me see, negative 3 minus 4 is negative 7. Negative 3 plus 4 is 1. So we got these results. Okay. So it's something of this nature. We do have the luxury of checking by plugging back into the original. Let's see, I think I'll use my calculator. Okay, so let's just see this in the original. I'm going to actually do it this way. So in the upper left hand corner, I'm going to click on my y equals, and I'm going to type the original in. We have x squared plus 6x minus 7. I'm going to quit. To the far right, you see the button clear. If I go left one down, nope. Let's see, what was I going to click on? To the far right, we see the button clear. To the left of that, I say VARS. I think that's like for variables. I'm going to go to the right to y variables. I'm going to click number 1 for function and number 1 for y1 because that's where I just typed that equation. And then I want to plug in when x is equal to negative 7 and the answer should be 0, and it is. And I want to do the same thing when x is 1 and the answer should be 0 again. Okay. So we checked both of these into the original and they both work, so we're going to go with them. Okay, yeah, so they got the same solution that we did. So I'll let you read through this on your own. Yeah, I'm just gonna let you read through that. I'm just gonna let you do that. Again, if anything isn't clear or if I need to go back, you have to reach out to me and I'll go back and do a dedicated video answering the questions. Let's give this one a go. Ask us to solve this equation by completing a square. So let's do the same thing. Let's get a copy of the original. I'm gonna have to crop some of this out. I'm gonna do something really quickly. Let's give this one a go. So we're asked to solve this equation by completing a square. I'm just going to do the same thing, all right? So let's see. We have the original is x squared minus 10x plus 21 equals 0. Some of my students did the following when they would work their equations. I like this, so I am going to borrow it. This line just helps us, tag on it. This line just helps us to identify so that we know that we're either working on the left side. Why is it not working it today? Let's try this one more time. There it is. So, as we kind of work through the equation, we're either working on the left side or the right side of this is going to be for our equal sign to line it up. Let's see. So the first goal, the leading coefficient needs to be a 1, and it is, so we're good to go. Next, we're going to move the 21 to the other side by using the inverse operation. What's the inverse operation of addition, or what's the opposite of addition? Is going to be subtraction. So we're going to subtract 21 from both sides. And then when we do this, we'll get the following. We have the x squared comes down minus 10x equals negative 21. So then again, the completing the square step is we do, we say plus b over 2 squared plus b over 2 squared. We do that on both sides, all right? Our b in this case is going to be the negative 10. So we're going to say plus negative 10 over 2 squared plus negative 10 over 2 squared. We do that on both sides, okay? Negative 10 divided by 2 is negative 5. Negative 5 times negative 5 is a positive 25. So we're really adding 25 on both sides of the equal sign. Okay, I'm just going to bring everything else down. Okay. So now on the left, we would like to factor, we should finish with some double blank parentheses, kind of like this. Negative 21 plus 25, that difference is what, 4. We have our x and our x on the left. Now we're looking for two numbers that multiply to give us 25 and add to negative 10, and they're going to be negative 5 and negative 5. So that means on the left we have x minus 5 squared equals 4. So now we take the square root on both sides. This square root cancels the square. Again, whenever we do square root, we have to introduce that plus or minus. And so then ultimately, we'll get x minus 5 equals plus or minus 2. So then x equals a negative 5 plus or minus 2. That's so now x equals negative 5 minus 2 is going to be negative 7. Negative 5 plus 2 is going to be negative 3. And I'm just going to check this up. Style. I'm just going to check this the same way. Well, again, we want to check. You should have noticed at least by the time. So the exams and the quizzes on Pearson should be similar as in formatting, and you should notice a difference. Like when you work on the homework, you have the question help, but then when you do a quiz, you don't have that kind of support. Like you have to know the answer. You don't get any support as far as help me solve this and all this other kind of stuff. So hopefully you're taking notes. You're being neat and organized, and I don't really get too many questions. But I usually don't get a lot of questions. Like students like to ask questions when they're in front of you, but they don't really go out of their way to ask questions. I would like to start doing some extra credit. Let's see. I got to think of some things. Okay. Okay. So let's do this. For every unique question let me see, not every. I don't know. But I can't think of anything. I'm totally sleepy. It's like the middle of the night. I hadn't decided. I got to think about that. But I want to offer some kind of extra credit. But it would help if you all were a little bit more engaged. And I hate to like dangle carrots out there, but that's usually how students respond. Like if I dangle a carrot of extra credit, then they usually start to jump on it. But that's neither here nor there. Yeah, I hadn't decided how I want to do the extra credit just yet. But yeah. But it is important that you kind of get engaged and that you ask questions. Check will show that 7. Is it 7 and 3? Oh, did we have x minus 5? Maybe I should have checked it. No, I think. Let me check it because I think we got different answers, right? Let me check this. Unless that was a different example. X minus 5? Or did I do it wrong? Oh, I did it wrong. Oh, okay, I see it. Okay, I see it. Yeah. So when you add 5 right here, that's supposed to be positive, positive, positive. 5 minus 2 is 3. 5 plus 2 is 7. Okay, that's better. Okay. Oh, that is one extra credit opportunity. So if like I actually almost walked away, I should have just left it. You know what? I'm gonna use it. I'm gonna put it back. I found it now. I'm just being my indecisive self. But the whole point is, if I do walk away from an example without checking it and it's wrong, I offer extra credit for those opportunities. So it's your job to kind of keep me honest. It's my job to be accurate and minimize mistakes like that. But if I had walked away from this one and left it the way it was, and you brought it first one to correct it or bring it to my attention, I offer extra credit for things like that. Okay. I think I'm not going to worry about the time and just kind of go through the material. Okay, I think that those are fine. Solve by completing the square. So I think we got another one. Let's just give this one a go. So it just skips. Just jump to example 4. I guess this is fine. Okay. So let's start by getting a copy of the original. We have this x squared plus 14x minus 26 equals 0. Okay, we're going to do the same thing. So first we're going to add the 26 to both sides, like this. And on here, this stays as x squared plus 14x. Next, we want to do our plus b over 2 squared. This green part is the completing the square step. Plus b over 2 squared, right? So that means what we're doing is plus 14 divided by 2 squared on both sides. Plus, let's move this up. We need a little bit of space. (14 divided by 2 squared). So what we're really doing, we're adding 7 on both sides, on the left side and right side of the equal sign. 26. The 14x comes down and the x squared comes down. All right. So on the left, we want to see, can we, oops, well, this is fine. We're trying to factor it into double parentheses. Our equal sign comes down. 26 plus 7, let's see, 4 and 3, 6, 12, 13. So then 33. Okay. We have our x and our x. 14. No, I'm totally messing up. 14 divided by 2 is 7. Squared is 49. It's going to be 49. Okay. So two numbers that multiply to give us 49, add to give us 14 are 7 and 7. Let's see, that's 60 plus 15 is 75. So then on the left, we get x plus 7 squared. Right, we get the 75. Okay. So then if we take the square root on both sides, I think this is okay. Remember, we got to do a plus or minus. So then we get x plus 7 equals, now 75 is what, 25 times 3? Square root of 25 is 5 times the square root of 3, right? So then x equals a negative 7 plus or minus 5 times the square root of 3. That's about the best we can do there, right? Because it's not a perfect square on the right. Yeah, this is how we're going to leave the answer. Let's actually see how to check this with our calculator. Okay. So first, let's kind of get a copy. Show the whole thing. Let's make it a little bit smaller. Or let's go like this. Okay, so we're going to try the same technique. We're going to put in the original. We have x squared plus 14x minus 26. Okay. I'm going to quit. And I essentially want to do the same thing. So I'm going to just call on that y1. Now for my x, the first one we're going to type is negative 7 minus 5 times the square root of 3. And the answer should be 0. Okay, that's essentially 0. That's times 10 to the negative 11. So that's a really, really, really small number, which is essentially 0. And then we're going to change that to a plus, and it should be something similar. Yeah, okay. So we're going to go with these results. Okay. Okay, so that actually closed out section 10.2. And give me just a moment. And we're going to go ahead and move into section 10.3, solving quadratic equations by the quadratic formula. So some objectives here are to solve quadratic equations by the quadratic formula, determine the number of solutions to a quadratic equation using the discriminant. So the thing with completing the square and the quadratic formula, whenever we have a quadratic equation, they can always be solved by completing the square or the quadratic formula if they're solvable. Yeah, we can always use those. It's just that they might not be the best route to take, right? So you want to have a few different options. But we can always use completeness square and quadratic equation to solve a quadratic. So we first, so we have this quadratic formula. One of my students remembers this formula in the following way. It is a good idea to commit this to memory. I'm not going to force it right now, but it is a good idea to commit this to memory, this formula. And the way that one of my students remembers this formula, they use the following story. They say the negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. So I thought that was a fantastic way to remember that. It might be a little bit, non-PC, but it makes it easier to remember. And I mean, obviously, it could be adjusted. I still hadn't figured out how I want to adjust it, but yeah. So let's try the quadratic formula here. Okay. So one of my mentors will say every time we use a formula, write it down. That'll help to ingrain it in our memories. So if we're going to use the quadratic formula goes x equals negative b plus or minus the square root of b squared minus 4ac, and it was all over by 2 a.m. All right. Another good idea here is to go ahead and identify our a, b, and c. So the formula is already in standard form. It's already set to 0. So then our a is going to be 1. Our b in this case is going to be 4. And our c is going to be 3. Okay. So then what we're going to do, we're going to say x equals negative b, so that's going to be negative 4 plus or minus the square root of 4 squared minus 4 times our a in this case is 1, our c in this case is 3, and it's all over by 2 times 1. All right, so let's simplify this result. Negative 4 plus or minus the square root, that's going to be 16. 4 times 3 is 12 over 2. 16 minus 12 is 4. Square root of 4 is 2. Let's see. So we have 2 different answers. Let me see. So then x is going to be, if we say negative 4 minus 2, that's going to be negative 6. Negative 6 divided by 2 is a negative 3. Negative 4 plus 2 is going to be negative 2 divided by 2 is negative 1. Okay. Okay. I'm not going to check this one. So I'm going to leave it. I'm not going to check it. I'm going to leave it. So like if it is incorrect, then I'm going to leave it for an opportunity for somebody to correct it and bring it to my attention, for one of my students to bring it to my attention. So again, with any example, if I walk away from the example and it's wrong, the first person that brings it to my attention, I usually offer extra credit for that. So the way I do extra credit is a point-based system. I usually log it, and at the end of the quarter, if I can apply the extra credit, I will. It's kind of one of those things where it's better to have it and not need it than need it and not have it kind of deal. Okay. So we got negative 3 and negative 1. Okay, I'm gonna let those be. Okay, we're actually using the quadratic to solve this one. Okay. Okay. So let's start by getting a copy of the original. We have x squared equals 6x minus 4. So the first thing, if we're going to use a quadratic formula here, we need to write it in standard form. Standard form is going to take on the form ax squared plus bx plus c equals 0. So long story short, we need to set this to 0 first. So we want to use the inverse operations. If we have 6x, the inverse operation is going to give us minus 6x. And then we're going to get plus 4 equals 0. Okay. So now it should be clear that our a is 1, our b is negative 6, and our c is 4. All right. So if we're going to use a quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. And that's going to be equal to negative 6 plus or minus the square root of negative 6 squared minus 4 times our a is 1 and our c is 4. Ran out of space there a little bit. Over 2 times 1. Okay? So that's going to be 6 plus or minus, that's going to be 36 minus 16 over 2. It's going to be 6 plus or minus, what is that? 20? The square root of 20 over 2. 20 is 5 times 4. Square root of 4 is 2. So that's going to be 6 plus or minus 2 root 5 over 2. And then we can take that one more step further. Divide both of those by 2. We're going to get 3 plus or minus the square root of 5. So again, I'm not going to check this one. Nope. So again, if any of these are wrong, if you check it, you shouldn't take my word for it. You definitely want to check these. Okay, just check them. If I'm wrong, bring it to my attention. I'll offer extra credit for that. Okay. Okay, let's do this one. Okay. So we're going to start with a copy of the original. We got this 9t squared equals 4. So first we should write this in standard form. So we're going to set it to 0. We're going to have 9t squared. I'm going to show you, this is the same as plus 0t minus 4 equals 0. Again, the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So then we see that our a is 9, our b is 0, and our c is -4. Okay. So what this means is that x is going to be, so you have -0. So, you know, plus or minus the square root of 0 squared minus 4 times 9 times -4 all over 2 times 9. Okay. If we keep going, we're going to get plus or minus the square root of 16 times 9. So that's 90 plus 36 is 126 over 18. So I'm going to write 126 in as prime factorization to get the square root. I know it's at least divisible by 2. I'm left with what, 63? So then 3 times 21. So then that's going to be another 3 times 7. And this should be right. Because we originally got it from, I think I might be missing a 2. Let's see, 63. 4. I feel like I'm missing a 2. Hang on. But I guess not. 18 times 7 or 9 times 9 times 14. Why is this not working out properly? Maybe I didn't multiply right. 4 times 4 is 16. Oh, 54. I surely did not multiply right. There it is. Okay. So 4 times 4 is 16. That's going to be a 90 plus 54 is 144. Okay. So this is not 126. Let's get rid of all of this. That's supposed to be 144. So then square root of 144 is what? 12 divided by 18. Let's see. They're both divisible at least by 2. So you get what, 6 by 9? So then they're both divisible by 3. 2 by 2/3, plus or minus 2/3. That's what we got. Why does it keep collapsing to a square? Okay. Again, we should check, but I'm just not going to. I'm going to leave that as an opportunity for you. But you see it there. Okay, let's give this one a go. Some things never change. So I totally have been like binge watching, like, I guess like Frozen 2 and like a bunch of Disney movies. So now those songs are totally stuck in my head. I'm just like, some things never change and some things do. I'm just like, oh my God, get out of my head, Disney. It's okay for now. Probably programming myself, but it doesn't matter right now. Okay. So, quadratic formula. Okay, so let's start by getting a copy of the original. We have this 3x squared equals x minus 1, right? Let's write this in standard form. So we need to set it to 0. So then we're going to have 3x squared minus x plus 1 equals 0. So now it should be clear that our a is 3. our b is -1, and our c is 1. So again, if we're going to use a quadratic formula, that's going to be x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Okay. So then this is going to be -b, so negative of -1 plus or minus the square root of -1 squared minus 4 times 3 times c all over by 2 times 3. So then that's going to be a +1 plus or minus the square root of 1 minus 12 over 6. And that's going to be 1 plus or minus the square root of -11 over 6. I'm not sure if we're going to, if they want to the complex, are they going to limit it to the reals? So we're going to say no solution or a non-real solution because we're taking the square root of a negative. Remember, we can't take the square root of negatives inside the reals. So right here, it says that since the square root of 11 is not a real number, we stop here. This equation has no real number solution. When given a problem of this type, the answer should be no real number solution. Okay. Again, right here, because we can't take the square root of negatives. Okay. So the discriminant is the expression under the square root sign in the quadratic formula. That's that b squared minus 4ac. The discriminant can be used to determine the number of real solutions to a quadratic equation. So for a quadratic equation in standard form, when the discriminant is greater than 0, the quadratic has two distinct real solutions, two distinct real number solutions. If the discriminant is equal to 0, the quadratic equation has one real solution, and if it's less than 0, it has no real solutions, no real number solution. Okay. And I mean, yeah, that's fine. To me, it's easier to see just by working an example. For instance, it said we're asked to determine the discriminant here. I'm just going to kind of follow what they have. We have this, so that means our A is 1, our B is -12, and our C is 36. So this comes out of the quadratic formula. This is going to be our b squared minus 4ac from the quadratic formula. So then that's going to be 144 minus 4 times a times c. 4 times 36, 144. So in this case, we get a discriminant of 0. So that means we're going to have one real number solution. Right? So it says determine the discriminant. So the discriminant in this case is 0. Then B, use the discriminant to determine the numbers of solutions. Since it's equal to 0, that's going to be one real number solution. Okay. Use the quadratic formula to determine the solutions of any. So notice that the discriminant was 0, so we just had one real solution. In this case, it's going to be 6. Oh, I think that closed out that section. So that closed out section 10.3, and we're going to go ahead and take some time to move into the last section for the day. We're going to move into section 10.5 on complex numbers. I hadn't realized that we hadn't talked about complex numbers yet. So we're going to take a moment, take some time to introduce complex numbers, and yeah, I'll go ahead and try to make sure that homework is assigned for these. I know that Pearson has been down over the weekend, so you're just gonna have to do the best that you can. But this is why these assignments are due. I try to get them up early in the week, as early as possible. We want to get our assignments submitted as early as possible, because websites like this, they do typically like shut down or they don't work when you need them to. So you definitely want to get these things submitted as early as possible. So let's look at this one. So some objectives here are to write complex numbers using I, add and subtract complex numbers, and solve quadratic equations with complex number solutions. So a complex number, square root of negative numbers such as square root of negative 11 are called imaginary numbers. Such numbers are called imaginary or non-real because when they were introduced, many mathematicians refused to believe that they exist. Although they do not belong to the set of real numbers, the imaginary numbers do exist and are very useful in mathematics and science. So the imaginary unit is going to be the square root of negative 1. Yeah, in mathematics, when something doesn't exist, you just give it a name and you just create it. And then you create a new system and you kind of keep moving. So when you need something that doesn't exist, you just create it, give it a name, and create a new system and proceed anyway. Yeah, let's keep going. So we have the square root of a negative. So for any positive real number n, when we take the square root of negative n, we're going to address the negative first. We want to rewrite it as I times the square root of n. So a complex number, every number of the form a plus bi, where a and b are real numbers and I is going to be the square root of negative 1, that's what we call a complex number, right? A plus bi. So this is sets in the numbering system. This is the sets. So whole numbers are going to be, oh, they don't have the natural numbers anymore? Okay. Whole numbers are going to be our positive counting numbers with 0. So we have 0, 1, 2, 3, 4, so on and so on. Positive counting numbers and 0. Integers are going to be basically the whole numbers with the negative counting numbers. So we have 0, 1, negative 1, 2, negative 2, 3, negative 3, so on and so on, going on forever in both directions. Rational numbers are going to be numbers that can be written as fractions of integers, where the denominator cannot be 0. Irrational numbers are numbers that cannot be written as fractions. The real numbers are going to be the rational numbers with the irrational numbers. The non-real numbers are going to be numbers of that have this a plus bi form. Pure imaginary is just going to be just the second part, this bi part, which is all of this stuff. And so complex numbers encompass all of these different kind of numbers. These are all considered complex numbers. So they kind of revamped this chart, which is interesting, and it's fine. Okay. So write each of the following complex number in the form a plus bi. Okay, we can just do this one over here on the side. So whenever we have a negative, whenever we have a negative inside the radical, we want to address the negative first, all right? So then the square root of negative 25, that square root of a negative is going to become I. So if we have 7 plus the square root of negative 25, that's the same as 7 plus, we're going to say the square root of negative 1 times the square root of 25. The square root of negative 1 becomes I, square root of 25 is 5. This becomes 7 plus 5i. Okay. And then this one, so that 24, let's see, 4 times 6, right? So then if we have 13 minus the square root of negative 24, that's going to be 13 minus, it's going to be I times the square root of, I want to say 4 times 6, because we want to try to get a perfect square. We usually put the I in front of the square root, but after a whole number or a number, right? So if it's by the radical, we put it in front of the square root. So the square root of 4 is 2. So then this is going to be equal to 13 minus 2i times the square root of 6. Okay. So again, as you kind of watch these videos or go through this material, if you have questions, you have to write them down and reach out. Otherwise, I'm not going to know. Okay, so to add and subtract complex numbers, we just add the real part with the real part and the imaginary part with the imaginary part. For instance, 9 plus 4 is going to give us what? 13. 2i plus a negative 6i is going to be a negative 4i. So it's going to be 13 minus 4i. Here's another one. Now we need to distribute this negative. If we do, we get this here, the negative 4 and a positive 3i. Now we're back to the one we just did. 5 minus 4 is going to be a 1. Negative 4 plus 3 is going to be negative 1. So that's going to be 1 minus I. Okay. Solve. Let's actually work this one out. Okay, let's get this one to go. All right, so we have, let's see, 2x squared minus 4x plus 7 equals 0. Can we find two numbers that multiply to give us 14 and add to give us negative 2? I mean negative 4. That's what, 7 and 2. I think that's it, right? So we can't just factor it the regular way. So we need to either do quadratic formula here or completing a square. I think I'm going to do, I was about to do completing a square, but again, with completing a square, the first step is that leading coefficient has to be a 1. So what that means is that we would have to divide all these by 2, and that means this is going to get divided by 2, and I know that fraction can kind of muck things up. So that means instead of doing completing a square, what I'm going to do, I'm going to use the quadratic formula. Quadratic formula, let me see, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So again, we could use completing a square here, but I felt like it would be a little bit harder because one, the leading coefficient needs to be a 1. So when we divide everything by 2, we're going to have fractions, and that's going to make things a little bit more challenging. So I'm gonna start with quadratic formula. Let's go ahead and we already have it set to 0, so then we should be able to identify our a. Our a is going to be 2, b is going to be negative 4, and our c is 7. Okay. So then that means our x is going to be negative 4 plus or minus the square root of negative 4 squared minus 4 times our a is 2 and our c is 7 all over 2 times 2. Okay, if we keep going, it's going to be 4 plus or minus, that's going to be 16 minus 56 over 4. We get 4 plus or minus, what is that? 40, 30, 40. Yeah, 40. Negative 40 over 4. Let's go ahead and find a non, like before we said it should have been a non-real solution, non-real number solution. But since we're in the complex numbers, I'm gonna go ahead and find the complex number here. 40 is 4 times 10. So I'm gonna rewrite that. Let me see, we got 4 plus or minus. So I'm going to rewrite it in the following way. Square root of negative 1 times the square root of 4 times the square root of 10. Okay. So then this gives us 4 plus or minus, square root of negative 1 is I. Square root of 4 is 2, so it's going to be 2i times the square root of 10 over 4. There are no perfect squares inside that radical. Everything is at least divisible by 2. So let's do the following. This is going to be equal to 1 plus or minus, let's see, let's do it like this. Root 10, nope. Root 10 over 2i. And we're going to go with this answer. Let's see, how do we do it? 1 plus or minus the square root of 10 over 2i. Uh-oh. 56. Yeah, okay, there it is. Yeah, so that's essentially the same thing. They wrote it different in a different form, but we got the same thing. Okay. All right, so on that note, we're actually gonna go ahead and end the session here, all right? So a few notes. So yeah, that closed out for chapter 10, what we would like to discuss on quadratics. We'll go ahead and assign some homework. We did have exam 1 that was due this past Saturday. I'll be on the lookout for a quiz this week. I think this is going to be a quiz week, okay? And we're just going to kind of keep moving forward with the material, okay? And if you have any questions, again, just write them down and you'd have to reach out to me. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day.